Hello my dear children, how are you all? Hope you all are fine over there. Once again welcome to the physics class of Sri Gokulam Public School, Guruvayur. Children, we were discussing about our second chapter, units and measurement. In the previous session, we had discussed about fundamental units as well as derived units. We also discussed fundamental and derived quantities. Apart from this, we discussed about two supplementary quantities, that was plane angle and solid angle. Today we will talk about the measurement of length, mass, time and distances of different scales. Which methods should we adopt in order to measure all these quantities of different scales? So let's get started with today's session, my dear children. So let's continue with the second chapter, units and measurement. Today we are going to discuss measurement of length. So first let's discuss the direct method to measure the length. This instrument on the screen is very familiar to you. This is meter scale and you will find such meter scales in your lab. This instrument is spherometer. This instrument is screw gauge. This is vernier calipers. So the spherometer, screw gauge and vernier calipers all are +1 practicals and you need to do some measurements using these three instruments. Okay. And this meter scale, screw gauge, vernier calipers, spherometer all helps us to measure length. And this spherometer as well as screw gauge is helpful to measure length in the millimeter scale. And this vernier calipers will measure length both in millimeter and centimeter scale. Okay, so all are direct methods to measure length. Then what will be the indirect method? And when do we use this indirect method? That is most important. Children, suppose you want to measure the distance of a planet from Earth or distance of a planet from Sun. Can you use this meter scale or can we use this screw gauge or vernier calipers to measure such large distances? No. So in such cases we will go for an indirect method. And what is that indirect method? That indirect method has got some name and that name is parallax method. So parallax method is an indirect method and we will employ such methods to estimate very large distances. That means beyond our scale. So what do you mean by this parallax method? What do you mean by this parallax? What is this parallax? To understand parallax in its best way, I will give you one example. In fact, let's all do one activity. Okay. So you first of all, you just aim at a spot on your wall. So anything will be there on your wall. So just aim at one spot, one black spot or any spot on your wall. Then try to view that spot by closing your right eye. Okay, just close your right eye and try to view that spot through your left eye. And just hold the pencil in front of your left eye against that point. Okay, are you ready? I hope you might have done that. Next, open your right eye, then close your left eye. Okay, now try to view the same point through your right eye. Okay. So can you feel any change in the position of the pencil? Yes. So there is a slight change in the position of the pencil. Right? So here is your two eyes and you are trying to view the one point on the white wall through your two eyes by closing the other eye respectively. So this is the distance from your eye and the spot. Again, this is the distance from second eye or eye to that spot. So both the distances will be same. What is this distance? this distance is the distance between two sides of observation. That means first you viewed this or observed this point from this eye. That means through your right eye. And then you viewed the same point or spot through your left eye. Right? So when you made observation from two different sides or through two different eyes, you felt a change in position of that spot. Right? And the change in position can be easily understood by the shift in the position of that pencil. First, the pencil will be here. That means when you view the spot with your left eye, the pencil might be here. And when you view the spot with the right eye, the pencil might have changed the position like this. So this phenomenon is known as parallax. Okay. Then there is a difference between the two sides of observations. So the difference between two sides of observations is called basis in parallax method. Basis B. Okay. Then here an angle is subtended through the point of or through the direction of observation. Okay. This is one direction of observation. This is another direction of observation. So the angle subtended by two different directions of observation is known as parallax angle or parallactic angle. Okay, so this is parallax method. And how we can employ this method to find out the distance of planet from Earth or to find out the diameter of a planet, that we can discuss now. Children, consider the figure on the screen. Here, S represents sun. A and B represents two different observatories which are located at two different positions on Earth. Now, the distance between observatory A and sun, let it be D, capital D. Now, the distance between observatory B and sun, it will be again same distance D, because both the observatories are located on Earth. Observatories means what? From where do we observe the planets or sun? Okay, that is observatory. Now, we need to find out the distance capital D. Capital D is the distance between Earth and the sun, or between the observatory and the sun. Since observatories are located on Earth, in fact, we are finding out the distance between Earth and the sun. So for that, we need to use our arc radius relation. So you might be wondering, where is arc here? What is radius here? So this A and B are located on Earth, and you know our Earth is having a curved shape. So this AB can be considered as a part of that curve. That means AB can be considered as an arc. So AB is the arc length, and we know the arc length. What is that arc length? It is B. Now if AB is a part of an arc, if we complete this arc, you will get a circle, right? If you complete this arc, you will get a circle like this. And what is the radius of that arc? Radius of that arc will be capital D. So use the arc radius relation. Now we got the arc length, we have the radius. Then what will be the plane angle theta? Plane angle theta is arc length by radius. And what is arc length? Arc length is B. What is the radius? It is capital D. If you know the basis B and angle theta, you can easily find out capital D. How? Capital D is equal to B by theta. So knowing B and theta, you can easily find out capital D. Thus the distance between Earth and Sun can be obtained using this parallax method. So it is an indirect method. Now see, using the same parallax method, you can easily estimate the diameter of a planet. So for that, consider the figure on the screen. Here, this represents a planet. and small d represents the diameter of the planet. A is the observatory which is located on Earth, and from that observatory this planet P is observed. So what is the distance between that observatory and the planet? It's capital D. Okay, now two sides of the planet, that means the diametrically opposite ends of the planet are observed from the same observatory A. Just reverse of the first case. We are observing two ends of the planet, and that two ends are diametrically opposite ends. So we are observing the two ends of the planet through the same observatory on the Earth. So how will you find out the diameter of that planet? Using the same arc radius relation, here we have an angle. An angle alpha is the angle subtended between two different directions of observation. So what will be angle alpha? Angle alpha is the arc length, and arc length is arc by radius. Here this diameter forms our arc and this capital D forms our radius. So our arc length is small d and our radius is capital D. So our angle alpha is equal to small d by capital D. And to know angular diameter small d, we can just multiply alpha with capital D. So knowing alpha and capital D, we can easily find out small d. Okay, so thus we can employ or we can use our parallax method to find out the angular diameter of the planet. Okay, so again it's an indirect method. Now children, what will you do if you want to measure very small distances such as size of the molecule, size of the atom, like that? And you might have an idea about the size of the atom. It is in the Fermi range, 10 raised to minus 50 meter, which is very small scale. So can you use this parallax method, or can we use that screw gauge or meter scale to measure such small distances? No, it's not possible. So for that we will use another devices, that is optical microscope and electron microscope. So this is optical microscope and electron microscope. So this is our optical microscope and this is our electron microscope. And both these microscopes helps us to estimate the size of the molecule or size of the atom, which is in the Fermi range, again which is in the angstrom range. 10 raised to angstrom range is 10 raised to minus 10 meter. And Fermi range is 10 raised to minus 50 meter, which is the atomic size. Okay, so to measure very small distances, we will use optical microscope and electron microscope. So that's all about the measurement of length. With this, I am concluding my session. A YouTube video based on the topic and notes of the topic have been uploaded. Please go through it. Also, there will be a small test based on this topic. Attend the test and post me the answers quickly. We will meet in the next session. Till then, take care, stay home, stay safe. Thank you.